Why do ordinary objects suddenly act like they have personalities when we get electrons involved?
Let's start with Scotch tape. When we stick these together and then peel them apart, friction transfers electrons from one piece to the other. Just like that, we've accidentally created the world's smallest and quietest electrical drama. One becomes negatively charged and the other becomes positively charged. And now if I bring the tape pieces back near each other, they will snap together like long-lost twins. And here's where it gets extra fun. If I bring one charged piece of tape near something neutral, like my balloon, it can actually polarize the charges in that object, which means the neutral object shifts its own charges around slightly, and suddenly the tape can attract it without even touching. And that, my friends, is why Scotch tape isn't just for crafts, it's for physics, and for causing tiny electric soap operas in your classroom.
Next up, balloons, hair, and a wall. Why does my hair suddenly think it's auditioning for a horror movie every time I touch a balloon? Here's what's going on. I'm rubbing this balloon on my jacket, which is basically friction in action. Electrons are getting transferred from my jacket to the balloon, making the balloon negatively charged. Now watch what happens when I bring the balloon near my hair. Yep, my hair is suddenly standing on end like it's trying to escape a static-themed haunted house. That's because my hair lost electrons and became positively charged, while the balloon has extra electrons. Because opposites attract. But here's the fun part. Even neutral surfaces, the wall, your desk, your unsuspecting backpack, feel the balloon's electric field. It polarizes charges in those objects, pulling the positives toward the balloon. And suddenly, the balloon sticks. Just like that. No tape, no magic, pure electrostatic attraction. So, by rubbing a balloon on my jacket, I'm basically creating a tiny, chaotic universe of charges. The balloon is clingy, my hair is dramatic, and everything around it just wants to play along. And that is why you should never underestimate a balloon, or your hair, when friction and electrons are involved.
This brings us to the question, why can I bend water like I'm trying out for Avatar: The Last Airbender? So here I have a charged balloon, and over here we've got water. Now watch this. Look at that. The water swerves just like it saw someone that they didn't want to talk to in public. So what's actually happening? Water molecules are dipoles, which means each one has a slightly positive side and a slightly negative side, kind of like tiny indecisive magnets. When I bring this charged balloon close, its electric field starts bossing the water molecules around. If the object is negatively charged, the positive ends of the water molecules swing toward it like, "Hi, hello, notice me." If it's positively charged, the negative ends rush over instead. Equal opportunity attraction. The realignment of the little dipoles is called polarization. And when the molecules start lining up, the whole stream gets nudged toward the charged object. So the stream bends, not because the water is dramatic, but because the electric field is literally rearranging the molecules inside of it. It's like the water trying to avoid conflict by moving directly toward the thing causing the conflict. Physics makes no emotional sense. And that is how you get a charged object to bend water, polarized to dipoles, electric fields, and a whole lot of molecular peer pressure.
And finally, why can I make my soda can chase my balloon across the counter like a confused metal puppy? So, I've got this charged balloon, yes, the same one that ruins your hair and your dignity, and I've also got this completely neutral soda can just minding its own business. Now watch what happens when I bring the charged balloon close to the can. The can is suddenly like, "Wait, come back, I love you." And I'm like, "Relax, we just met." Here's what's really happening. The can is a neutral conductor, meaning it has equal amounts of positive and negative charges, and the electrons are free to move around like they're at a Black Friday sale. When I bring this charged balloon nearby, it polarizes the charges in the can. That just means the electrons in the can shift around. If my balloon is negatively charged, the can's electrons freak out and run to the far side, leaving the near side more positive. So suddenly, the side of the can closest to the balloon is slightly positive, and because opposites attract, the can gets pulled toward the charged object. which is why it starts rolling after it like it's in a low-budget rom-com. The whole thing is called attraction by induction. The charged object never even touches the can. It just shows up like, "Hey, I have charges." And the can goes, "Say no more," and moves. So next time you see a soda can rolling across the counter like it has a crush on you, remember, it's not haunted, it's just physics being adorable.
So, in summary, tape fights, balloons cling, cans chase, and water dodges, all because of electrons, friction, and a little molecular drama.
Physics, turning ordinary objects into attention seekers, since forever.